Orbital motion is the way something moves in a circle around a larger object in space. Imagine a ball on a string. You swing the ball around and around your head. That's similar to orbital motion. In space, it's not a string that holds things together, it's gravity. Gravity is a force that pulls objects toward each other. The bigger the object, the stronger its pull. Orbital motion is everywhere in space. Planets orbit stars, moons orbit planets, and even stars themselves orbit the center of their galaxy. Without orbital motion, our universe would be a very different place. Gravity is the invisible force that makes orbital motion possible. It's like an invisible rope that keeps things from flying off into space. The strength of gravity depends on two things: mass and distance. The more massive an object, the stronger its gravitational pull. The closer objects are, the stronger they pull on each other. In orbital motion, there's a balance between the object's tendency to move in a straight line and gravity's pull inwards. This delicate balance keeps objects moving in their orbits. It's like a continuous tug-of-war that results in a circular or elliptical path. The Earth and the Moon provide a perfect example of orbital motion. The Moon orbits the Earth because of Earth's gravity. The Moon is constantly being pulled towards the Earth, but its own motion prevents it from crashing into us. The Earth, in turn, orbits the Sun because of the Sun's much stronger gravity. This interplay of gravity and motion creates the beautiful dance we see in the night sky. The Moon's orbit around Earth is not a perfect circle, it's slightly oval-shaped. This means that sometimes the Moon is closer to Earth and sometimes farther away. Section 4. Planets and their sun-centered paths. Just like the Earth and Moon, all the other planets in our solar system orbit the Sun. The Sun's massive size gives it incredibly strong gravity, which keeps all the planets in our solar system in orbit. Each planet has its own unique orbit, determined by its distance from the Sun and its speed. Some planets, like Mercury, have very fast orbits, while others, like Neptune, move much more slowly. The planets' orbits are not perfectly circular either. They're slightly elliptical, just like the Moon's orbit around Earth. This means that planets are sometimes closer to the Sun and sometimes farther away during their journey through space. Section 5. Satellites, our eyes in the sky. Humans have also launched artificial satellites into orbit around Earth. These satellites serve various purposes, from communication and navigation to weather forecasting and scientific research. They stay in orbit due to the balance between Earth's gravity and their own velocity. Think of it like this: if you throw a ball horizontally, it will eventually fall to the ground due to gravity. But if you throw it fast enough, the curvature of the Earth will cause the ground to fall away at the same rate the ball falls. This is essentially how satellites stay in orbit, constantly falling towards Earth but never actually hitting it.